Hi, let's learn some questions from the chapter 1. Okay, so the question is students perform the same experiment separately, and each one of them recorded two readings of mass, which are given below. Correct reading of mass is 3 gram, 3.0 gram. On the basis of the given data, mark the correct option out of the following statement. See, the student A got two readings like 3.01, 2.99, and B got 3.05 and 2.95. Now, the options based on this question, results of student A are both precise and accurate. Results of both students are neither accurate nor precise. Results of student B are neither precise nor accurate. The results of student B are both precise and accurate. See, and you check the answer. 3 gram is the actual mass, correct reading of mass. So student A got the values, both the values near to that correct one. So that is the answer. Both are precise. Option A, results of student A are both precise and accurate. Okay. See, the average of readings of student A, that is 3.01 plus 2.99 by 2, will be 3. But the readings of student A are close to each other as well as close to the average value as compared to the values of B. Okay. See, both the values are close to the average value also. So the results of student A are both precise and accurate. Now, second question. A measured temperature on Fahrenheit scale is 200 degree Fahrenheit. What will be the reading be on Celsius scale? 200 degree Fahrenheit corresponding temperature in degrees Celsius. How to calculate the relationship is note down this equation. Degree Celsius is equal to 5 by 9 into degree Fahrenheit minus 32. That is F minus 32 is equal to 9 by 5 into C, or C is equal to 5 by 9 into F minus 32. So F by 9 into 200 minus 32. So 5 by 9 into that value will get 93.3. Okay, just calculate and ensure the answer. Next question is, what will be the molarity of the solution which contain 5.85 gram of NaCl per 500 ml? What is the equation for molarity? Molarity is number of moles of solute divided by volume of solution in liter. So the question, there is no mole. Mole is not given. So what we want to do? We have to calculate the number of mole. Number of mole is equal to mass divided by molar mass. Mass divided by molar mass. So mass is 5.85 gram divided by molar mass is sodium chloride molar mass is sodium 23 and 35.5. So that is 58.5. So 5.85 divided by 58.5 is equal to zero point 0.1 mole. Next one, volume of the solution in liter. Here it is 500 ml. So 500 ml divided by 1000, that is zero point 0.5, zero point 0.5 liter, half liter. So molarity is equal to number of mole divided by volume of solution in liter, zero point 0.1 divided by zero point 0.5, that is zero point 0.2 molar. Clear? Next question. If 500 ml of a 5 molar solution is diluted to 1500 ml, what will be the molarity of the solution obtained? And we know that equation for dilution, that is molarity equation, is M1V1 equal to M2V2. M2 is equal to M1V1 by V2. M1V1 by V2. M1 500, V1 5 molar divided by 1500. and you will get option A 1.66 molar. Clear? Now the next question, the number of atoms present in 1 mole of an element is equal to Avogadro number. Okay. Which of the following element contains the greatest number of atoms? See the number of atoms present in 1 mole of an element. 1 mole of an element contains Avogadro number of particles. If so, which of the following element contains greatest number of atoms? So you have to find out the number of mole in each case, so that if the number of mole is high, number of atoms will be high. Number of mole into Avogadro number, that is the number of particle. Okay. So here 12 gram of helium. 12 gram of helium. 12 by molar mass of helium is 4. So what is the answer? 12 by 4? 3. Please note down in your book. Okay. I cannot write on the screen. That's why I'm dictating. Okay. So number of mole in 12 gram of helium is equal to 12 divided by molar mass. Molar mass is 4. 12 by 4 is 3 mole. Next one, 4 gram of helium. 4 gram of helium is 4 by 4, that is 1 mole. Then 46 gram of sodium. 46 gram of sodium equal to 46 by 23, that is 2 mole. So first option 12 gram helium is 3 mole. 4 gram helium is 1 mole. 46 grams sodium is, that is 2 mole. Then 0.40 gram by of calcium, that is 0.40 divided by 40, at least very less number, isn't it? The number of atoms is equal to number of mole into molar mass, sorry, number of mole into Avogadro number. So in the first case 3 into 6.022 into 10 raised to 23, then second one 1 into 6.022 into 10 raised to 23, next one 2 into 6.022 into 10 raised to 23. And 0.40 calcium contains zero point 0.1 mole. So 0.1 into 6.022 into 10 is 23. So out of which this is having maximum number of unit? 12 gram of helium. Clear? So 5 questions are over. Next question. If the concentration of glucose in blood is zero point 0.9 gram per liter, what will be the molarity of glucose in blood? Okay. See, molarity is equal to concentration in gram per liter divided by molar mass. 1 minute. Molarity. Okay, what will be the molarity of glucose in blood? First of all, they have given concentration of glucose. So that is zero point 0.9 gram per liter. Then molar mass we need to calculate. So molar mass is equal to what? C6H12O6. So 6 into 12 plus 12 into 1 plus 6 into 16. And we will get molar mass as 180 gram per liter. Now what is the equation for molarity? It is number of mole divided by volume of solution in liter. And they have given like this. Volume of solution in liter, right? So they have given like concentration in gram per liter. So what is concentration in gram per liter? That is mass of that solute divided by volume of solution, isn't it? So இப்போ நாம number of mole calculate பண்ணணும்னா mass by molar mass வரும். So mass by molar mass divided by volume of solution in liter, that is the exact equation. அதில் மாஸ் பை வோலியத்தை மட்டும் கன்சிடர் பண்ணும்போது அதுதான் கான்சன்ட்ரேஷன் சொல்லிட்டு தந்திருக்கு. ஸோ தட் கான்சன்ட்ரேஷன் டிவைடட் பை மோலார் மாஸ். ஓகே, தட் இஸ் த how that's why how we got such an equation. Next one, so we will get 0.9 divided by 180 and 0.005 molar solution. Okay. Next, what will be the molality of the solution containing 18.25 gram of HCl gas in 500 of gram of water. Molality. Okay. Molality of the solution. Number of moles of solute divided by mass of solvent in kilogram. Okay. So, number of mole calculate பண்ணனும்னா mass by molar mass. So, mass is WB, molar mass is MB. So, W by MB divided by WA, mass of solvent in kilogram. That kilogram to calculate that into kilogram, WA by 1000. So அப்படியே இந்த equation வந்து WB into 1000 by MB into WA. See, WB is mass of solute and WA is mass of solvent. Then MB is smaller mass of solute. Okay. So HCl mass is 18.25 and molar mass is 36.5. Then molar mass of solvent is 18. Okay. And this molality is equal to 18.25 into 1000 by 36.5 into 500. So 18.25 by 36.5 will be 1 by 2 and 1000 by 500 will be 2. So 2 by 2 is 1 molality, 1 molal solution. Clear? Next. 1 mole of any substance contains 6.022 into 10 to 23 atoms and molecules. Number of molecules of H2SO4 present in 100 ml of 0.02 molar H2SO4 solution is. See, 1 mole is equal to 6.022 into 10 raised to 23. 0.02 molality, molar, not molarity, molar. Okay, 0.02 molar solution is equal to 0.02 into 6.022 into 10 raised to 23. So that 2 into 6.022 will be 12.044. And finally, considering that 10th power also, finally we will get which answer? 10 raised to 20. Okay. See, 0.02 0.02 when I'm 2 into 10 raised to minus 3. 0.1 கூட multiply பண்ணும்போது 2 into 10 raised to minus 3 வரும். Okay. So number of moles கண்டுபிடிச்சாச்சு, molarity தந்தாச்சு. So number of molecules 12.044 into 10 raised to 20. What is the mass percentage of carbon and carbon dioxide? How we can calculate carbon mass percentage of a substance in a compound? That is mass of that substance divided by total mass of the substance. Mass of that element, one element, divided by mass of the whole compound into 100. So molar mass of carbon is 12. 12 divided by carbon dioxide வந்து 44 வரும். 12 by 44 into 100 and finally we'll get 27.27 percentage. Clear? And 10th question, the empirical formula and molecular mass of a compound is CH2O and 180 respectively. The empirical formula of a compound is given as CH2O and molecular mass is given as 180 gram. What will be the molecular mass of the compound? So, how to calculate that? First of all, molecular formula is equal to N into empirical formula. And the empirical formula is CH2O. And empirical formula mass we need to calculate, that is 12 into 1 plus 1 into 2 plus 1 into 16. And we will get 30 gram. Then molecular mass equal to 180 gram. So N number of mole N is equal to molar mass divided by empirical formula mass. It's not number of mole, it is actually that that term N which need to multiply with the empirical formula to get the molecular formula. So molar mass divided by molar mass is the mass of that molecule. Empirical formula oda mass the empirical formula mass. So 180 by 36. Now we need to multiply that 6 with the formula CH2O. So CH2O into 6, C6H12O6. Clear? Okay, so 10 questions over from this chapter. Okay, next question. So in this, it is match the following. You have to match molarity and the corresponding unit. Okay, molarity. What is the unit of molarity? Then mole fraction. Mole fraction is unitless, right? Mole is mole. C2. Okay, C2. Then that B4. 1. Sorry, A corresponding one is mole per liter. Molarity. So mole, number of moles per volume of solution in liter. Mole per liter. A 5. B mole fraction unitless. Mole. Molality, number of mole divided by kilogram or number of mole per kilo. Number of mole per was mass of solvent in kilogram. So mole per kilogram. Then pressure Pascal. Luminous intensities candela. Density is gram per ml. Then mass is kilogram. Okay. This is the match the following. Go through it. You can pause the video and note down the question. Then you can do it yourself. Okay. Again match the following. 88 gram of carbon dioxide. 88 gram of carbon dioxide. Corresponding answer. Molar mass of carbon dioxide is 44. So 88 by 44, 2 mole. 6.022 into 10 raised to 23 molecules of water. That is 1 mole. Okay, B4. Then 5.5 liter of O2 at standard temperature and pressure STP. C is 1, that is 0.25 mole. 96 gram of oxygen. 96 gram of oxygen. Okay, that is one oxygen molecule mass is 16 to 32. So 96 by 32. That is 3 mole. D is 3. Then 1 mole of any gas contains Avogadro number of particles, that is 6.022 into 10 raised to 23 molecules. Now in this question, the reactant which is entirely consumed in a reaction is known as limiting reagent. That's correct. In the reaction, 2A plus 4B gives 3C plus 4D. When 5 moles of A react with 6 moles of B, then which is the limiting reagent, and calculate the amount of C formed. See, already one equation is given. Then when 5 mole of A reacts with 6 moles of B, then which is the limiting reagent, calculate the amount of C formed. So the answer is, see, it is clear from the above equation that 2A means 2 moles of A requires 4B, that is 4 moles of B. Okay, so that is the ratio of A is to B is 2 is to 4. That is 1 is to 2. Abdina, 5 moles of A, the moles of B required is, that is 5 into 4 by 2. 5 into 4 by 2. That is 10 mole. Okay, 1 is to 2 ratio varno. Appa 5 is to enna varno. 5 is to 10 varno. Okay, but we have only 6 moles. Okay, we have only 6 moles of B. Hence B is the limiting reagent. Okay, we have only 6 moles of B. Hence B is the limiting reagent. Next, calculate the amount of C formed. Okay, since 4 moles of B gives 3 moles of C, hence 6 moles of B will produce, see 4 moles of B gives 3 moles of C. Abdina, 6 moles of B will produce what? 3 by 4 into 6. Okay, 3 by 4 into 6. That is 4.5 mole of C. Okay, so what is limiting reagent? The reactant which is entirely consumed in a reaction is known as limiting reagent. Hope this question is clear. Next question. 4 gram of NaOH dissolves in 36 gram of H2O. Calculate the mole fraction of each component in the solution. Okay, mole fraction. Mole fraction equation you know, right? Also determine the molarity of the solution. Molarity of the solution. First of all, given values we need to write. Mass of sodium hydroxide is 4 gram. Mass of H2O is 36 gram. Then molar mass of NaOH. Molar mass of NaOH is sodium 23, oxygen 16, and hydrogen 1. 23 plus 16 plus 1, that is 40. 40 U. Number of moles of NaOH. Number of moles of NaOH is equal to mass of NaOH divided by total mass of NaOH. 4 by 40.1 mole. 4 by 40.1 mole. Now the molar mass of H2O. Molar mass of H2O is 18. 18 U. So number of moles of H2O is equal to 36 by 18. That is 2 mole. 36 by 18, 2 mole. Okay, clear. Now what is the mole fraction equation? Number of mole of A, that is a component A, divided by total number of moles of all the components. So in this one, water mole fraction is equal to number of mole of water divided by number of mole of water plus number of mole of NaOH. So 2 by 2 plus 0.1. 2 by 2.1 is 0.95. Okay. Then mole fraction is equal to mole fraction of NaOH is equal to number of mole of NaOH divided by number of mole of NaOH plus number of mole of water. Okay. Then mass of the solution is equal to, next what is, also we need to find out the molarity. Okay. Now we got mole fraction of both NaOH and H2O. Next one is molarity. Molarity calculation kaga mass of solution കണ്ടുപിടിച്ചാച്ച mass of water plus mass of NaOH. Okay. So 36 plus 1 minute, 1 minute. So mass of solution, uh, 1 minute. Mole fraction of NaOH also we got. Next one is volume of solution. Molarity, no? So volume of solution is 40 ml. Okay, 40 ml. So we need to convert that into liter. Then number of moles of the solute is 0.1 mole. NaOH is the one. Okay. And mass of the solution is actually taken is calculated by adding mass of NaOH and mass of H2O, because we didn't get any what volume of solution in this, isn't it? Adnala mass of solution kandupidichachu, and they have already given specific gravity of the solution. It's not a specific density. Okay, density of the solution is 1 gram per ml. So 1 gram per ml means 1 gram na 1 ml. Okay, or 1 ml oda value the 1 gram. அப்படின்னா mass of solution 40 gram இங்க கிடைச்சிச்சு. இப்போ mass of water 36 mass of NaOH தந்தது 4 add பண்ணும்போது 40 gram கிடைச்சிச்சு. Okay, so volume of solution is equal to 40 gram into 1 gram per ml. Okay, mass into density. See, mass by volume is density. So then mass is equal to volume into density. Sorry, volume is equal to that 40 into 1 gram per ml. That means what? 40 by maybe some mistakes will be there. Okay, wait a minute. See, we know mass by volume is density. Density is 1 gram per ml. Appadina volume is equal to mass by density. Here 40 by 1. Adhanalada this is 40 into 1 gram per ml is wrong. Okay, 40 by 1. 40 by 1 is 1 and gram per ml வந்து மாறிடுச்சு. அதனால 40 ml னு வந்துருச்சு. ஓகே, புரிஞ்சுதா? நீங்கள் அந்த இக்குவேஷனை போட்டுட்டு மாஸ் பை வால்யூம் இஸ் டென்சிட்டி அப்படின்னா வால்யூம் இஸ் ஈக்குவல் டு மாஸ் பை டென்சிட்டி. மாஸ் இங்கே 40 கிராம் தந்திருக்கு. டென்சிட்டி வந்து ஸ்பெசிஃபிக் டென்சிட்டி. ஓகே, நாட் கிராவிட்டி. 1 கிராம் பர் எம்எல். அப்போ 1 கிராம் பர் எம்எல்லோட எம்எல் வந்து நியூமரேட்டருக்கு போயிடும். ஸோ கிராம் கட் ஆச்சுன்னா 40 ml. புரிஞ்சிருச்சா? சிம்பிளாக சொல்லணும்னா 1 கிராம் பர் எம்எல் மீன்ஸ் 1 கிராமுக்கு 1 ml. அப்போ 40 கிராமுக்கு 40 ml. அப்போ 40 ml volume of solution கிடைச்சாச்சு. அதை லிட்டரில் கன்வெர்ட் பண்ணணும். ஸோ நம்பர் ஆஃப் மோல் ஆஃப் solute, that is 0.1 divided by 40 by 1000, that is 0.04. So 0.1 by 0.04 is 2.5 molarity. Okay, clear? புரிஞ்சிருச்சா? See, next question. Volume of a solution changes with change in temperature. Then will the molality of the solution be affected by temperature? That is a question. See, molality of the solution is number of moles of solute present per kilogram of solvent. So, as molality is expressed in mass, therefore, molality of the solution is not affected by temperature. Okay. മാസ്നാല് தானே தந்திருக்கு மாஸ் per that is kilogramமில் தானே தந்திருக்கு ஸோ வால்யூம் ஆஃப் த சொல்யூஷன் சேஞ்சஸ் வித் சேஞ்ச் இன் டெம்பரேச்சர் ஆனால் மாஸ் வந்து சேஞ்ச் ஆகாது ஸோ மொலாலிட்டி ஆஃப் த சொல்யூஷன் தென் வில் த மொலாலிட்டி பி அஃபெக்டட் தட் இஸ் அ கொஸ்டின் மொலாலிட்டி அஃபெக்டட் ஆகும் ஆனால் மொலாலிட்டி அஃபெக்ட் ஆகலை ஏன்னா இந்த கால்குலேஷன் வந்து மாஸ் பேஸ் பண்ணிட்டு தான் இருக்குது ஸோ இட் இஸ் நாட் அஃபெக்டட் பை டெம்பரேச்சர் கிளியர். See, now we'll be discussing the questions from second chapter, structure of the atom. From the first chapter, almost 10 to 15 questions we completed. Now, second chapter, okay, structure of the atom. Wait a minute. The number of radial nodes for 3p orbital is. Answer is given 1. How? See, for p orbital, that is n equal to 3, l equal to 1. P nam 1, L is 1. So number of radial nodes is equal to n minus L minus 1. Appo radial nodes equal to of 3p orbital is equal to n 3, L 1. 3 minus 1 that is 1. Okay. Next one, angular nodes of 4d orbitals. Angular nodes of 4d orbitals. So number of angular node is equal to L itself. So 4d orbitals la n வந்து 4, L is d, that is d orbital no. So L equal to 2. So L equal to 2, so angular node also equal to 2. Okay. Then which of the following is responsible to rule out the existence of definite paths or trajectories of the electrons? Heisenberg uncertainty principle or Pauli's exclusion principle, Hund's rule of maximum multiplicity, of Bohr principle. See, you have to learn all these laws. Okay, all these principles you need to learn. In this question, the answer is Heisenberg uncertainty principle. See, according to this, it states that it is impossible to determine simultaneously the exact position, exact momentum of an electron. It rules out the existence of definite paths or trajectories of electron and other similar particles. At the same time, we cannot say about momentum and the position. Okay. Next, total number of orbitals associated with the third shell will be. See, number of orbitals is equal to n square. So third shell means n is 3. So number of orbitals is n square, that is 9. So which are that? 3s இருக்கு 3p 3d இருக்கு 3sல 3sல 1 ஆர்பிட்டல் இருக்கு 3pல px py pz 3 ஆர்பிட்டல் இருக்கு dல 5 இருக்கு so 5 plus 3 plus 1 9. Clear? Then orbital angular momentum depends on orbital angular moment depends on L. So what is L? L is azimuthal quantum number, which is also known as orbital angular momentum or subsidiary quantum number. It defines the three-dimensional shape of the orbital. For a given value of n, one can have n values. Okay, L ஓட values range வந்து 0 to n. Okay, 0 to n. Sorry, 0 to n minus 1. 0 to n minus 1. So, total number of L value will be n itself. So, if n is 3, L will have the values, 3 values. How? 0, 1, 2. Okay, clear? 0 to n minus 1. This is the values of L. And total, it is having n L values.
The pair of ions having same electronic configuration is Fe3 plus and Mn2 plus. Okay, Fe3 plus order value 26, Mn2 plus atomic number, Mn order atomic number 25. So Fe3 plus வரும்போது 3 electron loss ஆயிடும், Mn2 electron loss ஆகும்போதும் same number தான் வரும். Then degenerate orbitals. Out of the following pairs of electrons, identify the pairs of electrons present in degenerate orbitals. N3, L2, M minus 2, MS minus 2, 1 by 2. 1 option 2 or 3 or 4 See, answer 1 and 4 they have given. 1 and 4 பார்க்கும்போது degenerate orbitals வரும்போது எப்படி வரும்னா, see, the energies of an electron in a multi-electron atom, unlike that of the hydrogen atom, depends on not only in its principal quantum number but also in azimuthal quantum number. Electrons of the same shells and same subshells have the same energy and they are known as degenerate orbital. அப்போ சேம் ஷெல்லும் சேம் சப்ஷெல்லும் வரும்போது டீஜெனரேட் ஆர்பிட்டல் ஆகும். இப்போ இங்கே வந்து L2 ஃபஸ்ட்டு கேஸில், இங்கே செகண்ட் கேஸில் L1 and 2, தேர்டில் 1 and 2, ஃபோர்த்தில் 2 அப்போது மல்டி எலக்ட்ரான் ஆட்டத்தில் சேம் எனர்ஜி, டீஜெனரேட் ஆர்பிட்டல் சேம் எனர்ஜினா அதில் சேம் ஷெல்லு வேணும், என்னும் சேம் ஆயிருக்கணும், எல்லும் சேம் ஆயிருக்கணும். ஓகே, which of the following sets of quantum numbers are correct? N1, L2. First one itself wrong. N2, L1. Okay, correct. M plus 1. 2 is correct. 3 வந்து 3, 2, minus 2. 3 correct. 4 3 L 4 வருது. L ஓட value 0 to n minus 1. So it will not be 4. Okay, this is wrong. So 1 and 4 is wrong. Answer 2 and 3. Show the distribution of electrons in oxygen atom using orbital diagram. Oxygen atomic number is 8. So 1s2, 2s2, 2p4. So the distribution இப்படி காமிக்கலாம். 1s2, 2s2, 2p4. 1, 2, 3 and 4. Which of the following orbitals are degenerate? 3dxy, 3d, 4dxy, 3d z square, 3dyz, 4dyz, 4dz square. Degenerate orbitals. Orbitals with the same shell and subshell are known as degenerate orbitals. About 3dxy, 3dz square, 3dyz are degenerate orbitals. Then 4dxy, 4dyz, 4dz square are degenerate orbitals. Calculate the total number of angular nodes and radial nodes present in 3p orbital. Okay, angular nodes is L itself. Radial nodes கண்டுபிடிக்கிறதுக்கான formula n minus L minus 1. So 3p na 3 minus 1 minus 1, that is 1. And 3p லோட angular nodes p க்கு 1, அதனால L is angular node equal to L, that is equal to 1. Next. Chlorophyll present in green leaves of plants absorbs light 4.62 into 10 to 14 Hz. So frequency is given. Calculate the wavelength of the radiation in nanometer. Okay, wavelength lambda. Lambda equal to C by nu. Okay. Now C equal to nu by lambda. So C by nu. C is 3 into 10 raised to 8 meter per second. It's not 3, 8 meter per second. Okay, that is 3. It's wrong given here. Then 4.62 into 10 raised to 14. So C by nu we will get 0.6494 into 10 raised to minus 6. Other nanometer express பண்ணிருக்கு. and this is belongs to visible range light of the spectrum. See, quantum number match the following. Principal quantum number will help us to find out the energy and size of the orbital. Azimuthal quantum number will give us the information related to the shape of the orbital. Magnetic quantum number will give the orientation of the orbital. Spin quantum number is based on the spin of the electron. Now match the following: Hund's rule, Aufbau principle, Pauli's exclusion principle, then Heisenberg principle. Hund's rule வந்து Hund's rule எப்படி இதில் வருது? Pairing of electrons இல்லையா? Pairing of electrons in the orbital belonging to the same subshell does not take place until each orbital is singly filled occupied. எல்லா ஆர்பிட்டலோட எல்லா இதுலேயும் ஒன் ஒரு எலக்ட்ரான்ஸ் ஃபில் ஆகுனதுக்கு அப்புறம் தான் சிங்கிளி ஒக்குபைட் ஆகுனதுக்கு அப்புறம் தான் பேரிங் நடக்கும். Aufbau principle 1. On the ground state of the atoms, orbitals are filled in the order of their increasing energy. Increasing energy orderல தான் fill ஆகும். Then Pauli's exclusion principle. Pauli's exclusion principle, first one, no two electrons in an atom can have the same set of four quantum numbers. இப்போ n, l, m, s இதெல்லாம் கண்டுபிடிச்சு எழுதும்போது ஒரே வேல்யூ வர்ற குவாண்டம் நம்பர்ஸ் எக்ஸிஸ்ட் ஆகாது. ஓகே, ஒரு சேம் குவாண்டம் நம்பர் உள்ள electrons will not be there. Heisenberg uncertainty principle. It is impossible to determine the exact position and exact momentum of a subatomic particle simultaneously. Okay, இதெல்லாம் படிக்கணும் ரேஸோட இதெல்லாம். Then psi square means probability density. Okay. Calculate the energy and frequency of the radiation emitted when an electron jumps from n3 to n2 in a hydrogen atom. n3லிருந்து n2விലേക്ക് ஜம்ப் ஆகுது. ஸோ n1 square n2 square. So, n1 is 2, n2 is 3. So wave number calculate the energy and frequency. Equations எல்லாம் படிச்சு வைக்கணும். Just go through this. RH1 by n1 square minus 1 by n2 square. RH ஓட வேல்யூ சப்ஸ்டியூட் ஆயிருக்கு. சென்டிமீட்டர் இன்வர்ஸில் கிடச்சிது. வேவ் நம்பரோட equation கண்டுபிடிச்சதுக்கப்புறம் வேவ் லெங்க்த்து 1 by lambda தான் வேவ் நம்பர். ஸோ lambda is 1 by wave number and finally we will get wavelength. Wavelengthலிருந்து எனர்ஜி கண்டுபிடிக்கிறோம். hc by lambda you will get it. h is 6.626 into 10 raised to minus 34. c is 3 into 10 raised to 8. Okay, 3 into 10 raised to 8 is needed. And finally we will get hydrogen atom. 3 into 3.028 into 10 raised to minus 90 joule. Table tennis ball has a mass of 10 gram and a speed of 90 meter per second. If speed can be measured with an accuracy of 4%, what will be the uncertainty in speed and position? See, delta x into delta p is equal to h by 4 pi. That is the Heisenberg uncertainty principle. இப்போ டெல்டா வி கண்டுபிடிக்கும் போது நாம் அன்சர்டன்டி ஸ்பீட்ஸ் ஆஃப் த டென்னிஸ் பால் கண்டுபிடிக்கணும். அதில் நாம் 4% தானே இதில் கிடைக்கிது, ஆக்குரஸிலே கிடைக்கிது சொல்லிட்டோம். 1 minute. So 90 ஓட 4%. 90 into 4 by 100, 3.6 meter per second. And uncertainty principle அல்ல position is delta xன்னு கன்சிடர் பண்ணியிருக்கு. அப்போ நம்ம uncertainty in ஸ்பீடும் uncertainty in position தான் கண்டுபிடிக்கணும் சொல்லியிருக்கு. இப்போ நம்ம ஹைசன்பர்க் அன்சர்டன்டி பிரின்சிபல் equation யூஸ் பண்ணிட்டு uncertainty in principle அல்ல பொசிஷன் கண்டுபிடிக்கலாம். டெல்டா எக்ஸ் ஈக்குவல் டு h by 4 pi delta p. h by 4 pi delta p, p equal to mv. So h by 4 pi m into delta v. ஓகே, டெல்டா வி தந்திருக்கு நமக்கு. அதுக்கு தரல, நம்ம கண்டுபிடிச்சிட்டோம் இப்போ அன்சர்டன்டி இன் த ஸ்பீடு. ஸோ அதை வச்சு டெல்டா எக்ஸை கண்டுபிடிக்கலாம். ஓகே, for 6.626 into 10 to minus 34 divided by 4 into pi 3.14 into 10 gram. So 10 into 10 to minus 3. Okay, 10 to minus 3. Then into 3.6 meter per second. That is delta we calculated, and finally we will get this 1.46 into 10 to minus 33 m. Okay, clear? That is position. I hope this is clear to you. The effect of uncertainty principle is significant only for motion of microscopic particles and is negligible for macroscopic particles. So justify the statement with the help of a suitable example. Delta V into delta x equal to h by 4 pi m. H is the Planck's constant. அதை சப்ஸ்டியூட் பண்ணிட்டு பார்த்தா இப்போது டெல்டா வி இன்டூ டெல்டா எக்ஸ் 4 into 3.14 into 10 raised to minus 6 தந்த வேல்யூ மாஸ் கொடுத்தா 0.52 into 10 raised to minus 28 meter square second inverse. The value obtained is extremely small and insignificant. Therefore, for a milligram sized macroscopic object, the associated uncertainties are hardly of any real consequences. So uncertainty principle is significant only for the motion of microscopic particles. Okay, not the macroscopic particle. Clear? Next. Wavelengths of some radiations are given. Increasing orderல arrange பண்ணணும். அது வந்து conversion புரியுதா தெரிஞ்சிருக்கான்னு டெஸ்ட் பண்ணுறதுக்காக இந்த equation. Nanometer means 10 raised to minus 9 meter. Micrometer is 10 raised to minus 6 meter. Again 3 nanometer given. 30 angstrom. Angstrom is 10 raised to minus 10 actually. Here they have given 3 into 10 raised to minus 9. Okay, 30 இருந்தது skip பண்ணி 3 into 10 raised to minus 9. இதில் which one is having the increasing order of their energy. இப்போ energy equation, energy is inversely proportional to wavelength. இப்போ wavelength decreasing orderல எழுதிருச்சுன்னா energy increasing orderல வரும். Okay, clear? Three hundred micrometer less than 300 nanometer, less than 3 nanometer, less than 30 angstrom. இதில் சிஎம் டியும் சேம். ஓகே, சிஎம் டிஎம் வேவ் லெங்க்த்து சேமாக இருக்கும். ஸோ லேம்டா பியோட லேம்டா இஸ் less than lambda A, less than lambda C and D. Okay. The arrangement of orbitals on the basis of energy is based upon their n plus L value. So சும்மா குறை ஆர்பிட்டல்ஸ் வந்து அதை இன்க்ரீஸிங் டிக்ரீஸிங் ஆர்டரில் அரேஞ்ச் பண்ண சொல்லிட்டுனா n plus L வேல்யூ கண்டுபிடிக்கணும். லோவர் த n plus வேல்யூ, லோவர் இஸ் த எனர்ஜி. And for orbitals having same values of n plus l, values same இருந்துச்சுன்னா n plus l ஓட value same இருந்துச்சுன்னா orbital with a lower value of n, இப்போ n plus l value same value ரெண்டுக்கும் கிடைச்சுன்னா எந்த ஆர்பிட்டலோட n value smaller அதுக்கு lower energy. அதே மாதிரி இந்த 1s 2s 3p 2p எல்லாம் அரேஞ்ச் பண்ண சொல்லியிருக்காங்க. ஸோ n plus l values of some 2s sorry 1s 1s 1 plus 0 வரும், 2s வந்து 2 plus 0 2, 3s வந்து 3 plus 0 3, 2p வந்து 2 plus 1 வரும், pக்கு l value 1, 2 plus 1 3 வரும். அப்போது 1sல 1s ஃபஸ்ட்டு, ஓகே, அதுக்கப்புறம் 2s, அதுக்கப்புறம் வந்து 2p வரும். ஏன்னா 2pயும் 3sக்கும் n plus l வேல்யூ 3 itself. அப்போது n வேல்யூ ஸ்மாலஸ்ட்டாக இருக்கிறது தான் least energy. Okay, so order is 1s 2s 2p 3s. Next one 4s 3s 3p 4d. Just you find out 4s na 4 plus 0 4, 3s na 3 plus 0 3, 3p na 3 plus 1 4, then 4d na 4 plus 2 6. அப்போ first வருது 3s, அதுக்கப்புறம் 3p வருமா, 3 plus 1 4, 4 plus 0 4. அப்போ 3pயா 4sஆ பார்த்தா 3p ஃபர்ஸ்ட் வேணும். அப்போ 3s 3p, அதுக்கப்புறம் 4s, அதுக்கப்புறம் 4d. கிளியர்? ஜஸ்ட் 5p 4d 5d 4s இல்லை 4f 6s பார்த்தா 5p 5 plus 1 6, 4 plus 2 6, 4d, 5d 5 plus 2 7, 4f 5 plus 3 7, 6s 6 plus 0 0. அப்போது எப்படி வரும் அதோட ஃபார்முலாஸ்? அதோட 4d 5p 6s 4f 5dன்னு வரும். ஓகேவா? ஓகே, this is one type of question. Now some questions from third lesson. Okay, discuss and compare the trend in ionization enthalpy of elements of group 1 . Discuss and compare the trend in ionization enthalpy of elements of group 1 with those of group 17 elements. So trends in ionization enthalpy can be explained on the basis of the atomic size and screening effect. See, down to the group, top to bottom partha, as we go from top to the bottom of the group, the atomic size increases due to the addition of one new principal shell at each succeeding element, and therefore the nuclear charge goes on decreasing due to an increase in the distance between the last valence shell and nucleus. So ionization enthalpy decreases as we move from top to bottom. Okay, then from left to right along the period, as we move from left to right in the period, the successive electrons are added to the orbital of the same principal quantum level, and this creates shielding effect. Shielding of nuclear charge by the inner core of electrons does not increase very much to compensate for the increased attraction of the electron to the nucleus. So the shielding effect is not that much focus. So nucleus is attracting the outermost electron close to it. Thus, across the period, increasing nuclear charge outweighs the shielding. Consequently, the outermost electrons are held more and more tightly, and ionization enthalpies increases across the period. Because in order to take out one electron that is very close to the nucleus is very difficult, so a large amount of energy is needed. So lithium to fluorine, that is lithium is first group, to fluorine second group, the ionization enthalpy increases while moving from lithium to rubidium and fluorine to statin. Ionization enthalpy goes decreases. Then you have to learn about Mendeleev's periodic table, and it's how does a modern periodic table is better than Mendeleev's periodic table, in what ways அதெல்லாம் படிக்கணும். And demerits of Mendeleev's periodic table you need to learn. Then Discuss the factors affecting electron gain enthalpy and trend in its variation in the periodic table. See, what are the factors affecting electron gain enthalpy? First one is nuclear charge. Greater the nuclear charge, greater will be the electron gain enthalpy. Then size of the atom. It is inversely related to size of the atom. As atomic size increases, electron gain enthalpy decreases. Because size increase பண்ணும்போது that electron gain enthalpy decreases. Then electronic configuration. Elements which have stable electronic configuration of half filled and completely filled valence subshell show less tendency to accept. If they are already half filled and if it is fully filled, electrons gain per tendency கம்மியா இருக்கும். So electron gain enthalpy is less negative. And how it is vary in a period and group. Electron gain enthalpy increases from left to right in a period as atomic size decreases. In a group, the electron gain enthalpy decreases from top to bottom in a group. Okay. See, assertion type question. Assertion. Generally, ionization enthalpy increases from left to right in a period. Now, the reason that have given us when successive electrons are added to the orbitals in the same principal quantum level, the shielding effect of inner core of electrons does not increase very much to compensate for the increased attraction of the electron to the nucleus. And the electron nuclear attraction விட higher and the shielding effect வராது. So, அதனால ionization enthalpy increases. Both A and R are true, and R is the correct explanation. See, ionization enthalpy increases from left to right across the period that due to a decrease in atomic size. The electrons present within the subshell has almost the same effective nuclear charge. Okay. See the table you need to know that is atomic radius of various atoms whether increasing or decreasing அதெல்லாம் தெரிஞ்சுக்கணும். See, Na plus cation, Na, which is bigger in size. The radius of Na plus cation is less than that of sodium atom. Give reason. The cations are smaller than their parent atom. Okay. Because they have lesser electron than that of the parent atom, but the nuclear charge remains the same. So remaining electrons held more tightly by the nucleus and their radius will become smaller than parent atom. Then metallic character left to right decrease ஆகுது, non metallic character increase ஆகுது left to right போகும்போது. Arrange the elements nitrogen, phosphorus, oxygen, sulfur in the order of increasing first ionization enthalpy or increasing non-metallic character. First one, ionization enthalpy increasing order na sulfur, phosphorus, oxygen, nitrogen. Ionization enthalpy increases from left to right in a period and decreases down the group. So N has higher ionization enthalpy than oxygen due to the extra stability of half-filled orbitals. Similarly, phosphorus has higher ionization enthalpy than that of the sulfur due to half-filled orbitals. Then increasing non-metallic character. Phosphorus, sulfur, nitrogen, oxygen. Non-metallic character decreases down the group and increases from left to right. So phosphorus, sulfur, nitrogen, oxygen. What is exothermic reaction? Energy is released in the form of heat or light. Other delta H is negative for exothermic reaction and delta H is positive for endothermic reaction where absorption of energy is taken place. How could you explain that the fact that first ionization enthalpy of sodium is lower than that of magnesium, but its second ionization enthalpy is higher than that of the magnesium? How? Electronic configuration of sodium and magnesium is 1s to 2s to 2p6 3s1 sodium, 1s to 2s to 2p6 3s2 magnesium. The first ionization enthalpy of magnesium is higher than that of sodium due to high nuclear charge and a slightly smaller atomic radius of magnesium than sodium, because sodium kind the magnesium left to right പോകുന്നത് size reduced ആയിടും. അപ്പോൾ അതിലിருந்து ഒരു ഇലക്ട്രോൺ എടുക്കുന്നത് கொஞ்சம் difficult. So ionization enthalpy of magnesium is higher than that of sodium. The electronic configuration of sodium and magnesium after losing one electron will become Na plus and Mg plus. அது எப்படின்னா 1s to 2p6 and 1 for Mg plus 1s to 2p6 3s1. இப்போ வந்து Na plus completely filled. After the loss of first electron, it formed Na plus formed has the electronic configuration of neon. Okay. 28 atomic number 10 electronic configuration 28 இருக்கிற நியோன மாதிரி ஆயிடுது. அப்போ வந்து higher stability. Higher stability of the completely filled noble gas configuration leads to very high ionization enthalpy for sodium. So Na plus ல இருந்து further one more electron எடுக்கிறதுக்கு high amount of energy is needed. ஆனால் Mg plus என்ன ஒன் லாஸ்ட் இல்லை 3s1 அதிலிருந்து ஒரு electron எடுத்தா கூட பரவாயில்ல. On the other hand, Mg plus formed after losing one electron still has one more electron in its outermost subshell, sorry orbital. Therefore, the second ionization enthalpy of magnesium is smaller than that of the sodium. This is one of a very important question. Okay. Then, why first member of each group of representative elements shows anomalous behavior? The anomalous behavior is due to their small size, high ionization enthalpy, high electronegativity, and absence of d orbital. For example, in case of S block elements, due to small size lithium form covalent compounds, while other alkali metals forms predominantly ionic compounds. And in case of carbon, due to small size and high electronegativity, it has strong tendency to form p-pi bond, either itself and other elements such as nitrogen, oxygen, and sulfur. Okay. See, nitrogen has positive electron gain enthalpy, whereas oxygen has negative. How? How oxygen has lower ionization enthalpy? However, oxygen has lower ionization enthalpy than nitrogen. Explain. See, nitrogen, see, this is because of the extra stability of half-filled 2p orbital of nitrogen than oxygen, as oxygen has 4 electrons in 2p orbital with the 2 electrons in the same orbital, which increased electron repulsion. Okay, so when electrons are added to the half-filled 2p orbital of nitrogen, energy is required. Therefore, nitrogen has positive electron gain enthalpy. And on the other hand, on removing one electron from 2p orbital makes half-filled stable 2p orbital. But in case of nitrogen, it becomes less stable. Therefore, first ionization enthalpy of oxygen is less than nitrogen. Clear? See, ionic radius is inversely proportional to the effective nuclear charge. If effective nuclear charge is high, ionic radius is less. You have to learn the pattern or the trends of properties like across the period எப்படி down to the group எப்படி அந்த மாதிரி எல்லாம் learn பண்ணிட்டே இருக்கணும். Okay.